Hi, my name is Pradeep Ganesh. I'm part of the Network and Edge team in Intel. I'm the product manager for the BirdStream platform and also the AI product manager for the Network and Edge workloads. Today we'll talk briefly about Xeon 6 because we have Xeon 4 and Xeon 5. The next in line in the roadmap is Xeon 6, which is going to be launching, which portion of it has been launched this year, and rest of it will be launching in Q1 of 2025. Let me share. So can you folks see my screen?
Yes, very good.
Okay, very good. All right.
Yes.
So briefly talking about Xeon 6, just some disclaimers that. So today's agenda, we'll briefly talk about Xeon 6, be introducing P cores and E cores, some of the key features of Xeon 6, and also I'm happy to introduce Xeon 6 SoC, which is a BGA version with integrated Ethernet. And I'll have some Q&A, time for Q&A. So Xeon 6 processors, codenamed Granite Rapids, Sierra Forest. The platform is BirdStream, and address a broad range of compute demands. And they achieve new levels of performance and efficiency in the data center environment and in the on-prem server environment and in the enterprise server environment. So across board, they establish leadership in computing. So from a Xeon 6 microarchitecture perspective, there are two microarchitectures in Xeon 6. Both are ISA compatible. One is Xeon 6 with efficient cores, which is the E cores, and another is Xeon 6 with performance cores, which is the P cores. Now, why two different microarchitectures? Right? So Xeon 6 is designed to address the market needs. There's a diverse market need, all the way from compute intensive and AI workloads to general purpose workloads. And then there is a high density and scale out workloads. So the P cores are optimized for higher single threaded performance. So if you need compute intensive and AI workloads, and then you gravitate towards the P core solutions. And if you have if your application is mostly microservice based and you need a lot of threads and you need better performance per watt, then you migrate towards E-core solutions, which is optimized for efficiency. So E-cores are significantly optimized for performance per watt, and P-cores are optimized to give you the best performance. So within the Xeon 6 processors, we have the solutions provide up to 288 cores, and then they have significantly increased memory bandwidth when compared to the Xeon 5, almost up to 1.7x. They also introduce Xeon 6 with P cores, also introduces MRDIMM, and this is a higher bandwidth memory capability, and which gives you almost up to 2.3x the performance benefit compared to the prior gen. And with PCIe Gen 5, you have increased I/O bandwidth. And then with the updated socket-to-socket communication, UPI, you have almost 1.8x the performance. And we also support CXL, Type 1, Type 2, and Type 3. The Xeon SP, and especially the P-core version, has socket scalability from 1 socket to 8 socket solutions. Also, there's an increased last level cache all the way up to 500 megs. And then starting from Xeon 4, we had introduced accelerator technology, and all the accelerators have been enhanced to give you the best-in-class accelerators in Xeon 6. Quick assist technology, in-memory analytics accelerators, data streaming accelerators, and dynamic load balancer. I'll briefly go about this in a later slide. And of course, Xeon 6 being the best-in-class AI accelerator built into the compute solution, it has through AMX, Intel AMX ISA extensions. And given this market segment, security is very critical, and Intel provides the best security solutions. Whether you need a small trust boundary or a large trust boundary, we'll talk a little bit more about this through Intel TDX and SGX. So whether you need application level security or you need a VM level security, we have solutions for both. So let's quickly see what the offerings are from a Xeon 6 with E-cores. Xeon 6 with E-cores has two series, the 6900 and 6700. They're different platforms because they have different memory channels. All of them are LGA. So 6900 provides you up to 288 cores, and 6700 provides you up to 144 cores. 6900 provides up to 12 channels of memory. 6700 provides you up to 8 channels of memory, but 6900 provides up to 96 lanes of PCIe. 6700 provides you up to 88 lanes of PCIe. And both are scale up to 2 sockets. And this is the efficiency cores based offerings. Now, if you look at the performance core offerings, you have the 6900, the 6700, rich one socket solution, and the 6700 series. So the 6900 again is a key point to note is the platform compatibility between the 6900 P core and the 6900 E core. And similarly, there's platform compatibility between 6700 E core and 6700 P core. And coming back to the 6700 series and 6900 series, the 6900 series P core provides you up to 128 P cores with 12 channels of memory and 96 lanes of PCIe. The 6700 series has two variations. One variation is 6700, which is single socket, optimized for single socket workloads. So you get more PCI lanes. So you get up to 136 lanes of PCIe. The 6700 with multi-socket capability gives you up to 86 cores, but only up to 88 lanes of PCIe. But it can scale up to 8 sockets. One thing I would like to call out here is Intel have, from a network and edge roadmap, we support the 6700 series. And similarly, in the E-core version, also we support the 6700 series. The 6900 series is more optimized towards cloud service providers. So what makes Xeon 6? What's the differentiating factors in Xeon 6? So Xeon 6 is, as of today, the world's best CPU for AI. Now, it provides you 128 cores per CPU, an increased bandwidth. Every AI model is very bandwidth hungry. So having the MRDIMM capability gives you industry-leading DDR bandwidth capability. And then large LLC, again, for AI models which are memory intensive, having a larger cache reduces your latency. And then you have your AMX instruction, which are ISA enhancements, x86 ISA enhancements. So it gives you in compute matrix multiplication capability, having 8 tiles, which can happen, giving you increased matrix multiplication happening in parallel. So this gives you a dynamic boost for all your AI models when run in compute. So especially very useful when you have hybrid compute environment where your workload has a portion of compute and then a portion of, it's doing a portion of AI or matrix multiplication. Then you have optimized, you have the compute which can be optimized for normal compute and also for AI compute. Similarly, they have other vector extensions like AVX512, which has been very useful in math operations, especially signal processing operations, which are used in radars and other defense-related workloads. And similarly, they have AVX2, which is which is a low power version and gives you capability for gives you a lower capability of AI if you don't want to use the AMX enhancements. What else is new and what else is the capability of Xeon 6? Xeon 6 has been built with PQC in mind, right? So there's a future of post-quantum crypto, and we have built the platform such that all the microcode signing is quantum resistant by using XMSS. Also, the total memory encryption has been updated to support AES 256 to make it quantum resistant. Similarly, the ISA CPU cryptographic capability instructions have also been updated to support AES 256 so that all applications can tap into being more quantum resistant and making it future proof. And then that is from quantum resistance perspective. And from a platform perspective, we have added PCI link protection. So a CPU, an add-in card, now can have a certain level of security against physical attacks because the link is encrypted. Similarly, socket-to-socket communication is also encrypted. So any kind of physical attack is thwarted to a certain extent because there's no data in clear, neither in the PCI lanes nor in the UPI lanes. And of course, Intel provides industry-leading confidential compute capabilities. Whether we have increased the number of keys for TDX. TDX is trust domain extensions, and this is the VM-based VM isolation solution from Intel. So we've increased the number of keys, so you can have 10x more confidential VMs per socket. And Intel provides SGX, and those have been the encryption, memory encryption, like we talked about, has already been updated to AES 256. So Intel SGX, which is application isolation, is also now strengthened to be quantum resistant. Intel also provides Intel Tiber Trust Service for independent attestation. So let's talk briefly about app isolation. So Intel SGX provides the smallest trust boundary and the greatest data protection and code integrity. So essentially, your application can run its own confidential enclave, protected from even the guest OS and host OS vulnerabilities. Now, in a scenario, if you would prefer to be virtualized and not just app isolation, you want your VMs to be isolated, then Intel provides trust domain extensions. Here, the trust boundary extends to the guest OS and the VM admin, but it is an order of magnitude better than not being in a TDX scenario. It's a non-TDX VM from a security perspective. And then if you want independent attestation and of your services, so that especially if you have records which need to be third-party audited, Intel provides trust services through Intel Tiber Trust and Security. Finally, I come to another very key differentiation in Intel Xeons, which is the accelerator engines. Intel provides, we talked about the AVX and the AMX accelerators. Now I want to talk a little bit about the Intel Quick Assist technology, which provides not only cryptographic acceleration. So let's say you're running a hybrid workload in a post-quantum in a post-quantum future. You're running a workload which is doing RSA, but also some post-quantum algorithms. You can run some of the post-quantum algorithms in the cores and offload the older algorithms to the Intel QuickAssist technology for significant performance reward benefit. Now there is hardware accelerators built in which accelerate RSA 2K, 3K, 4K, and or any kind of AES, GCM, XDS, and Chacha Poly, and all of these are offload to built-in accelerators, so the cores can be free to do other stuff. Intel Quick Assist also provides compression acceleration, and this provides significant improvements in throughput. So you can and also supports chaining flows where your data can be compressed and then encrypted, and then you generate hashes for making sure data integrity. And all of this can be offloaded to the accelerator engine in a single pass so that your cores don't have to worry about any of these flows. Intel also provides dynamic load balancer, which is specifically built for networking flows. It provides a dynamic load balancer is basically a hardware queue manager engine. So each connection has different queues, and in large flows, offloading the queue management to hardware provides a significant boost to the performance. And Intel also provides data streaming accelerator, which is essentially a hardware DMA. And a new feature that Intel has provided from Xeon 4 is the in-memory analytics accelerator, which provides significant boost to in-memory analytics. So your analytics in DDR will get, through a compression decompression capability, provides significant boost to analytics in memory. So these are some of the key differentiating factors from a Xeon 6 perspective. I want to take some time to introduce Xeon 6 SoC. Now, Xeon 6 SoC is the same P cores, but in a BGA form factor. But what it also has, it increases the integration that's happening in the SoC. It includes industry-leading Ethernet and accelerators for media and VRAM. So there's two offerings, and this is going to be in a BGA form factor because it has integrated Ethernet, and it comes in a 4-channel and an 8-channel memory solution. It provides just like Xeon 6. It provides support for MCR DIMMs, but it has integrated Ethernet. So it provides you 8 ports of Ethernet. It can be configured 2 by 100, 4 by 50, or 8 by 25, 10, and 1. It does provide 48 lanes of PCIe, 32 of it which can be PCI 5.0, and 16 of it which is 4.0. And it introduces, because it is optimized, Intel Xeon 6 SoC is optimized for the edge. It has integrated accelerators which are predominantly used in the edge, on-prem to the edge server scenarios. It has a media accelerator, so it can do all your transcoding, which is very, very important for media delivery scenarios. And it provides quick assist technology for security and compression. And it provides VRAM boost, which is actually provides you significant accelerator capability from like FEC and FFT and those kind of 5G algorithm enhancements which are offloaded to hardware so that you can save your cores for other application related processes. Finally, Xeon is Xeon 6900 was launched in September. Happy to say that portions of Xeon 6, like this XCC versions, have been PRQ'd. Now we'll be launching 6900E and 6700. The rest of the Xeon 6 SoC and the 6700s and the lower core count versions of it all in the Q1 of 2025. So I'll pause here for questions.